Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Triangulation is brought to you by Cashfly at CACHEFLY.com. This is Triangulation, episode 219, recorded Monday, October 5th, 2015. Max Lobovsky and the Form 2. Triangulation is brought to you by Braintree. Looking to set up payments for your business? Braintree gives your app or website a payment solution that accepts just about every payment method with one easy integration. Plus, Braintree will give you the first $50,000 in transactions fee-free. To learn more, visit BraintreePayments.com/triangulation. And by Epson's new EcoTank printers. With Epson's line of SuperTank all-in-one printers, you can print thousands of documents without running out of ink. EcoTank is loaded and ready to print when you are. Visit Epson.com/EcoTank to find out more. And by Samsung SmartThings. Samsung SmartThings lets you monitor, control, and secure your home from wherever you are using your smartphone. Right now, Triangulation listeners get 10% off any featured SmartThings kit and free shipping in the U.S. when you go to smartthings.com/triangulation and use the offer code Triangulation at checkout. Time for Triangulation, the show where we get together with some of the most interesting, smartest people in technology. And I learn a lot, and I hope you enjoy it. I think you're going to learn a lot and enjoy this next interview, because our guest today is the co-founder of Formlabs. Max Lobovsky joins us. One of the most successful Kickstarter campaigns to date, the Formlabs 3D printer. It's right behind him, the brand new model. Max, welcome to Triangulation.
Thanks for having me.
Nice to have you. You started at MIT's famed Media Lab many moons ago, like a couple of years ago.
Yeah. I just as I finished up at the Media Lab, I started Formlabs. So that was my last job.
When you went to MIT, did you think that you were going to be doing 3D printing? What were your interests at the time when you began?
Well, actually, before that, I was at Cornell University as an undergrad, and I was working on one of the first open source desktop 3D printers. It was a project called the Fab at Home.
Oh, great!
So
great.
I was kind of into this whole desktop 3D printing thing from the beginning.
Did it start in high school? When did it begin?
I guess I started working on it in undergrad at Cornell.
Yeah.
I'd known about 3D printers before then. I remember my father brought home a part when I was like probably 7 or 8 from one of the first 3D printers that ever existed. But yeah, I started working on it in undergrad.
You come by it honestly. What did your dad do?
He was an engineer at Honeywell at the time, and they were prototyping a new type of water turbine, actually.
And printing it in a 3D printer.
Mm-hmm.
And that's really what's happening here, because 3D printers have been around in industrial design for a long time, but they've been big, they've been expensive. What we're seeing now is desktop printing, which is exciting. Mm-hmm. Do you liken it to the revolution that personal computing went through when it went from big honking computers that no one could get access to except the priesthood and to the desktop computer? Is it that kind of transformation?
Yeah. A few people have tried to make that analogy, and I think they're, without trying to draw it too closely, I think there's a lot of things you could learn by looking at it that way, because at say in the 60s and 70s, computers were mainly these really big mainframes operated by professionals and used by big businesses for very important stuff, but only a few of the applications that could have benefited from it were able to because of the cost and accessibility. And then people started working on making them more accessible, and that's when the explosion really happened.
What happened to Fab at Home? It's still around?
It's still going. It's still going in some form, but I think those early projects sort of were more important in inspiring people, and today most of the technology development is being done by companies like ours.
Building the community around it so that you could then go ahead and start making products out of it. I like it because instead of a 3D printer, the Fab at Home thing was an open source personal fabricator. And I kind of like that name. I almost wish we kept that idea. It's a fabricator.
You know, when we were starting Formlabs, we were trying to, figure out what are we going to call this thing, because there's a lot of different names that have been used in the industry before: additive manufacturing and solid freeform fabrication, and we liked the fabricator name the best, but when we looked at what people would actually recognize the most, we had to stick to the 3D printer.
Yeah. So the Kickstarter project raised $2.9 million. It was at the time the most successful Kickstarter. This was what, 2013?
2012.
2012.
Yeah, September 2012.
And I think one of the reasons it was so successful, I mean, Replicator was around, we'd seen other 3D printers, but yours looked cool. It was the best looking 3D printer I've ever seen. Was that part of the intent?
I hope there's more to our success than just that.
Sure there is.
But industrial design is a huge part of what we do here. And we knew from the beginning that if we want to sort of deliver on this vision of making these things more accessible and friendlier and easier to use, the image and the ergonomics and the actual machine that you interact with, making that look nice and work well is going to be a big part of that. So our industrial designer, Joao Brejes, was actually the first employee at Formlabs.
And by the way, the new one, the Form 2, looks even sweeter. I like the front panel there. That looks really cool.
Thank you.
So you're paying attention to that. But of course, it's got to do what you say it's going to do. And it's also got to be easy to do. And I think that's one of the things, my experience with 3D printers is it can be a little bit frustrating because you have to tend to the thing a lot and it's slow. And but I guess also early personal computers were slow and you had to tend them a lot too. We're still in the early days, I guess, is what I'm saying. Definitely.
People have made that PC analogy a lot, but sometimes they're a little naive about it, and they say that that computers went from mainframes to a PC on everyone's desktop, and that was like one jump. And Apple released the Macintosh, and then boom, the jump was made. That's not really what happened. What happened was there was probably a 15 or 20-year period where most of the sort of action was in expanding the range of professional users of PCs. And so most of the people buying the Apple II and then the Macintosh were people using it for work of some sort. And so I think that's actually sort of the phase we're in now, where we're not at mass consumer 3D printers. We're at, they're tools for professionals, but now it's not just for people who have really extreme, unusual needs, but for anybody who's working in 3D.
Right. It's gone from hobby. You feel like it's gone from hobbyist now, though, to, and you used that word professional back in 2012 for the Form 1, to a professional thing that people can use for to get actual work done.
Exactly.
Yeah. We're talking to Max Lobovsky. He is the co-founder of Formlabs, one of the early and most successful 3D printing companies. Bree Pettis I've known for years, and of course he ended up selling to a big 3D commercial 3D printing company. Do you want to keep Formlabs small, or would you like to do that at some point? He got a little heat for doing that, I think.
He did. Yeah, I think there's a third option other than keeping it small and or selling it to a big company. You can grow a big independent
make your own company. Yeah.
Yeah, and I think that's the goal we're all most excited about here. But the world changes, and we'll do what makes sense to continue pushing this technology.
Can't make any promises, but yeah. MakerBot was around when you created Form 1, right?
Yep.
What lessons did you take from MakerBot, and what things did you say, I'm going to do this differently or better?
Well, so yeah, MakerBot was a huge inspiration and reference point, and they were the most successful people in this field when we got started, and so we tried to learn as much as we could about them. And I've told Bree this as well, that we probably would never have started this if we hadn't seen that you could really start a company selling something like this and just sort of start it out of your garage.
They led the way, yeah.
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 But part of why we wanted to start Formlabs is looking at all of the other desktop 3D printers at the time. We knew there was a big gap there between what was out there and what was possible in a desktop machine, because we had worked with a lot of the higher end machines, and we had built 3D printers of our own, and we knew it was possible to build something that was both easier to use and more capable.
Yeah. I want to take a little break. When we come back, I want to go back a little bit to the Media Lab and the Bits and Atoms department, which is the division of Media Lab. You did your was it bachelor's and master's work in?
That was master's.
Master's degree. Okay. We're talking to Max Lobovsky, co-founder of Formlabs. What are you printing back there?
I'm actually not totally sure.
You just press start?
Somebody set up this job. I think it's might be a belt buckle.
Cool.
It's a nice sample part that we make. Yeah.
Very cool. And we'll talk about the new printer and what you can do with it, and why you might want to run out and get one of your very own. Form 2 is called the most advanced desktop 3D printer ever made. But we'll have more in just a second. First, a word from our sponsor, Braintree. If you're a mobile app developer or a web developer and you're looking for a way to do payments, look no farther. Braintree is here to save your bacon. Now, I don't mean to say that you can't do it yourself. You could. You got the time. You're willing to, the boss is willing to spend the money. You could. But it's a lot of work, and there's risks, because we're talking about people's money here. And the experience is so important. Did you know that 70% of mobile carts are abandoned before the person checks out? That's a lot of money left on the table, and that's mostly because people don't get what's going on. They don't trust what's going on. They're not satisfied with the experience. That can all change with Braintree and their V.0 SDK. 10 lines of code you can put in your modern app that gives you payments for everything. We're talking Apple Pay, Android Pay, PayPal, Venmo, of course credit cards, even Bitcoin. And you know what was cool? When Android Pay came online a couple of weeks ago, if you were using Braintree in your app, all you do is go to the control panel, check a box, boom, you're done. This does it. It gives fast payouts, great support for you, a great experience for your customers. And I can tell you, you've used it. You just don't know it, because Braintree is what Uber uses. Friction-free, right? It's part of the new Pinterest buyable pins. That's how they do that. Airbnb uses it. GitHub. Come on, you use GitHub, right? GitHub uses Braintree. You could use Braintree right now. Go to the sandbox, try it out, see what your code would look like, see what how it would work for you. You'll see fewer abandoned carts, you'll see more sales, you'll see happier customers, and you will be happier, and your boss will be happier. And as a little sweetener, the first $50,000 in transactions are fee-free. BraintreePayments.com/triangulation. BraintreePayments.com/triangulation. I've been doing this ad for a while, and we used Uber the other day, and I was thinking, it never says Braintree, but man, that's a nice experience. Just get out of the car, done, send your receipt, love it. Try it out for yourself. BraintreePayments.com/triangulation. Max Lobovsky is our guest. He is co-founder of Formlabs, which makes a beautiful 3D printer that is for professional use as well as hobbyist use. What would you say is how many? It's still mostly hobbyists using these, right?
It's actually 90% business customer.
Really? Interesting.
Yeah. So we were surprised as well as we saw that develop from Kickstarter going on. But most of the customers, and that's what this machine is ultimately designed for, is people who are doing professional work with 3D models.
Give me an example of some of the things people are doing with it.
So there's a really wide range. I got one sample part here that this is from a local company called Bounce Imaging. They're a startup that's developing this ball that has a number of cameras in it, and the idea is that police departments or fire departments would use it to inspect an area that they don't want to go into, so they can just toss the ball in and get sort of a 360 video feed.
Cool.
From the room.
So they're making a prototype then.
Exactly. Yeah. So that's a big chunk of the customers are people prototyping a new product. As far as we know, every Fortune 500 company that makes something has a Form 1, Form 1 Plus. And yeah, it's mostly sort of prototyping applications. But then there's a number of other customers. There's people in the movie and game industry who print out models of the characters or sets that they're working on as they're designing them in 3D. There's jewelers, that's a big segment, who actually print out patterns in our castable resin, which then they can turn into a final ring through a casting process. And there's some dental applications as well.
Oh, interesting.
So quite a number of different users.
So it's not just PLA that you're printing with. You have stuff that's a little bit that can actually be used for lost. How does it work, casting?
So the way it works, roughly speaking, is you print out a pattern that looks like the part. You print it in this blue castable resin that we have, one of the 7 different resins that we have. And then you put it in, you pour kind of a plaster around it, ceramic that solidifies around that part. And then you put that whole thing into an oven and you burn out the part. So typically it's done with wax. Our material is not exactly wax, but the same thing happens.
Right.
Where when you
kind of lost wax casting.
Yeah, so it sort of burns away or evaporates the part, and then you're left with a cavity in the ceramic, which you can now pour molten metal into.
That's really cool. And of course, for a jeweler as well, that's how you would make it. And dental work too, I guess.
Yep.
That's how you would do it. So tell me about MIT. You graduated from Cornell. What was your degree at Cornell?
I studied applied physics there.
Neat. You'd want to be a physicist?
I think at some point, yeah. And then the more I learned, the more I realized that I want to work on something a little more near term. And I like to I need the result to see the results of my work sort of more in front of me, which is difficult in physics.
Yeah. So you went to the Media Lab at MIT, which is of course legendary, a place where so many interesting ideas have emerged. And in the Bits and Atoms department. What is that?
Yeah, it's called the Center for Bits and Atoms. And that's a group led by Professor Neil Gershenfeld. And it's a really unique place. I don't know of any other group like that at another university. And the goal is to work on projects that either apply computer science to the way we make things or understanding of the way we make things to computer science, and sort of try to take a lot of the knowledge from the two worlds and bridge them together. So there's some projects about computing with bubbles, or there's projects about redesigning computer circuits to better match the actual structure that they're made out of. And I worked on a project, a modular robotics project, where we were trying to build this type of chain robot that can fold into any shape. And the long-term goal is to make matter reconfigurable.
Wow.
So
that must have been so fun.
It's a pretty fun place, and there's really a lot of amazing people there.
Yeah. You're working with some of the smartest people in the world. But you weren't doing 3D printing stuff there at first?
Yeah, it wasn't really part of my research, but I saw you brought up the webpage for the Fab Foundation, for the Fab Lab program. So that was another thing going on at the Center for Bits and Atoms, was that we would support building out this network of Fab Labs, which Fab Lab is sort of another type of maker space or hacker space. There are different names for it, but I like to describe it as a machine shop crossed with a library.
Oh,
so
neat.
It's sort of like a community center with tools in it, and there's a couple hundred around the world. And so we would kind of, as a side project, we would go to different locations and help them set up Fab Lab or train them or teach classes. And these Fab Labs have a lot of tools like desktop 3D printers. And so this is where I sort of really got to see the power of what happens if you bring these capability to make things to a wider audience. What do people do with it, and how does it change their lives? And so that was a lot of the inspiration for wanting to work on desktop 3D printers and bringing them to the world.
So after Fab Lab, is that when the Formlabs kind of became a genesis of an idea in your head?
Yeah, I mean, as we were, me and the other two co-founders, who are also at the Media Lab, we were finishing up our master's degrees, trying to figure out what to do next. And
that's always the challenge, isn't it?
Yeah, and it was actually a tough period, honestly, because nothing felt right until we landed on this idea. But between seeing what Fab Labs were doing around the world and seeing the success, but also challenges that MakerBot and others had, and then having had access to all of these high-end 3D printers that you mentioned at the beginning, these big, expensive, but really awesome machines, which we were lucky enough to have at the Media Lab. We sort of said, why isn't there something that bridges all these things? Why can't we take the capability of those big machines and bring them to these desktop machines?
Of course, there's a big difference in cost. Those big machines might cost hundreds of thousands of dollars. How much was the Form 1 Kickstarter?
The Form 1 was $3,300. Now that we've introduced the Form 2, lowered it to $2,800.
Still expensive, though, compared to, say, a replicator.
Actually, Form 1 is now cheaper. Form 1 Plus is now
cheaper than the replicator.
Yeah.
Okay.
Yep.
But not a casual purchase by any means.
No, it's there's two different worlds. We're coming from these $50,000-$100,000 machines, and then a true mass consumer printer might be $500 or $1,000. So this is somewhere in the middle. But for professionals, it's still quite affordable. The way you might think about it, if you're an engineer who's making 3D products as part of your job, this is kind of like buying a nice laptop for the job, which is not a huge deal. If you need a laptop at any big company, you get one.
Yeah.
And that's the idea, that we would want to have that same experience if you're looking to buy a 3D printer.
When you did the Kickstarter, had you made a prototype? Had you already created the first Form 1, or? We had
been building. There's a nice museum at the office of sort of the sequence of prototypes. And we had built 4 or 5 different iterations, and we had gotten to the first prototypes of what looks like the Form 1 today. So the industrial design and things like that were set. And we had that, and it was working, but there was also a lot of work left to do before shipping it.
And that's, of course, in the days when Kickstarter didn't require like kind of a working prototype, but
I think they actually introduced those rules like 1 week before we started.
Surprise!
But we satisfied those rules.
You were ready, yeah.
Honestly, you could still screw up your Kickstarter pretty badly even with satisfying those rules.
Oh, absolutely. God knows. So it must have been exciting when you go live on Kickstarter. What were your hopes? I mean, in your wildest dreams, what did you think might happen?
Yeah, I mean, of course, we were all arguing over how big it would go, and we had very little to base it on. But I think everybody assumed that $1 million campaign would be a really big success, like something that would be doable but would be amazing.
Yeah.
And
how much did you ask for?
We asked for $100,000.
Okay.
So I think we were comfortable that we were going to get past that.
Yeah.
But nobody thought anything like $3 million. That was crazy.
How many is that? I'll have to do the math.
It's about 1,000 machines.
Wow. Were you surprised at the depth of interest in 3D printing at this point?
Yeah, I mean, the fact that we went like overnight from 10 or 12 people in a room with nobody knew anything about us to literally next day every single tech publication talked about us, and we were 3D printing and Formlabs was sort of something being widely discussed in technology. That was incredible. We did not think that could happen.
And I think it's really interesting because the MakerBot really was, I think, a hobbyist machine at that point. Anybody who bought a replica, maybe, I don't know, maybe I just don't understand the market. I find it fascinating that 90% of your customers were going to use it in business. They weren't just tinkerers. They were going to use it to do prototyping. There was a pent-up demand for inexpensive prototyping 3D printers.
3D printing has been around long enough that a lot of people working with 3D design had gotten some interaction with them.
They wanted them.
Much fewer people, much smaller set of people actually had regular access to them, and most people were limited by having to wait in line to use a shared printer or having to send out for expensive parts. So a lot of people knew about it but didn't have access that they'd like.
Yeah, clearly. When you sold 1,000 of them, that's fantastic. So now, in some ways, this is the worst possible scenario. You have $2.9 million, and now you got to deliver 1,000 machines. Did you feel up to that challenge? Obviously, you did it.
Yeah, it was. We knew it was a really big challenge, and the funny thing is how quickly it sort of comes, because the way Kickstarters usually go is there's usually a huge spike right in the beginning. So we had already sold $1 million in 2.5 days, I believe. So,
wow. That's fast. Holy cow.
Yep. I think on the first day we were like the second largest company in 3D printing or something like that, if you counted for that day.
That's incredible. That's great. That's so nice.
But so we were, had to start dealing with the reality very quickly. And we had been planning to set up a contract manufacturer and be building lots of these machines, more than just what we needed for Kickstarter. But this went beyond what we were planning for. So it definitely was. You had to change plans very quickly.
And of course, you were sued immediately.
Yeah. So within about a month after the Kickstarter, we had a lawsuit.
You don't want to attract attention. Sometimes it's nice to stay under the radar. This was one of the big 3D printer companies that went after you.
Mm-hmm.
They said that the technology that you use, is the technology the Form 1 uses substantially different than the replicator?
Yes.
It's stereolithography.
Yeah.
What is that?
So it's so in 3D printing, kind of like in 2D printing, there's different processes. So in 2D printing, there's inkjet and laser and dot matrix, and different processes are good for different things. They have different capabilities. So in 3D printing, the process that MakerBot and all the other desktop machines use is FDM, fused deposition modeling, where you sort of extrude plastic and lay it down layer by layer.
Right. We've all seen it, happening. Yeah.
And what we use is called stereolithography, which is actually the first 3D printing process developed. And the way this works is there's a bath of liquid photopolymer resin. So this is basically a liquid plastic. It's kind of like a glue that when it's hit with a certain wavelength of light, it solidifies. And so you scan a layer with a laser or some other light source, and wherever the laser goes, it solidifies a thin layer, and then you lift that layer up and repeat the process layer by layer. So if you can see the light flickering in the machine behind me, that's the laser scanning.
That's a really cool way of doing it. Almost counterintuitive. I would, if you asked me to invent 3D printing, I would have done the deposition model. This is a lot harder to do, it seems like. And yet, does it produce a better result?
So yeah, the advantage is for stereolithography is really great surface finish and really fine details. So compared to FDM, so you can do these really fine detailed parts. So like I have this little chess piece model here, and this might be a little hard to see on the camera, but there's some, and you probably can't see there, but there's some really fine text on the top of the model. There's also freestanding like helix inside. So you can do these really tiny details that you can't do on other processes, and you also get the smoother surface out of it. And the other nice thing about stereolithography is you can do a really wide range of materials. So these are the 7 different materials we make. You can do clear. This is unpolished. If you polish it, it gets even more clear, but you can see that it's actually reasonably transparent.
Yeah.
You can do that castable resin, which I showed you. You can do a flexible resin.
That's cool.
Yeah. So there's a lot of capabilities you can get in the machine, and really great detail.
So it doesn't come in a reel like PLA does. How does it? How does the material? Or is it a tank? What am I going to?
So for the Form 1, it comes in a bottle, and you pour it into the machine.
Okay.
One of the things we introduced with the Form 2 is a cartridge system.
Nice.
So this actually slides in the top of the machine in the back, and feeds the machine automatically.
So this seems like, I mean, I've had problems with the reel-based printers because they always seem to need a lot of attention and tending, and the reels things get off, and you got to adjust it constantly. This seems like a more reliable, more robust way to do this, actually.
I don't know if the process is like fundamentally more reliable, but making the machine reliable is a huge focus. So especially moving from the Form 1 to the Form 2, most of the work we put in was to control more things about the process, remove more of those variables, to make the process more reliable. So we kind of believe that reliability is sort of a dirty secret of 3D printing, where everybody has this, who hasn't used a printer, has this image that, oh, you just press print from your computer and then it comes out and it's perfect every time. But especially with the desktop machines, that's rarely the case. Usually it's more like you spend some time setting your model up on the computer with some knowledge you have about the machine, then you press print, it comes out, either not at all or roughly correct, then you adjust some settings and print it again. And that really does not deliver on the promise of 3D printing.
Yeah. And it's one of the things I think that scares a lot of people off, having had experience in the early days and how finicky and tricky it is to get a good result. I'm thrilled that you've been able to focus on making this a little more robust and reliable, and that's of course what's going to make the transition to making these much more common. This is the video of the Form 2. So is it available today?
So we're taking orders today. We'll be shipping in November.
I want one. This looks so magical when it's making the stuff, and the fact that you can use all these different materials is really intriguing, especially the flexible material. There seems like there's so many things you could and of course the molding material, the lost wax style resin. Very cool. We're talking to Max Lobovsky about the new Form 2 printer. He's the co-founder of Formlabs. The company did the Form 1, hugely successful Kickstarter project. Form 2 is now or just about to come out. And is very exciting. I've got a lot more to talk about, but let's take a break and talk about a different kind of printing, one that's perhaps a little more mature, a little more well-known. We're talking about inkjet printing, but even inkjet printing can get better, and Epson has done it again. Of course, we told you just a few months ago about their new precision core technology. This is the very high-resolution quality printing that came down from their industrial printers. We're talking 40 million drops per second. I mean, just incredible performance. Now they've introduced the EcoTank, and they've paired the two up. And at this point, it's just a no-brainer. You need to get the new Epson EcoTank printer, like this ET4550. In the box, comes with enough ink for roughly 2 years, about 50 ink cartridges. That's 11,000 black pages, 8,500 color pages. There's no ink cartridges in there, though. It's a tank. It's equivalent of 50 ink cartridges, but you won't be going to the store to get more ink for around 2 years. High-speed printing because of the precision core, great colors, laser quality black text, and no more out of ink. No more, got to get more cartridges, and that brings the cost down too. Low-cost, ultra-low-cost replacement ink means you're going to love this printer for a long time to come. All the EcoTank printers, and there are many models at many different price points, deliver an unbeatable combination of convenience and value. You're just going to love this. I think you're really going to love this. The freedom to print without running out of ink. Epson's done it again. I'm a huge fan of, as you know, the workforce printers with precision core technology. And now the EcoTank means, well, it's even better, especially if you're in one of those offices where you do a lot of printing. 20,000 pages on the WFR 4640. That's just amazing. That's the high-duty, high-volume. Epson. Epson.com/EcoTank. Visit the website to learn more, to transform the way your home prints, your office prints, your work group prints. The best combination of value, ease, simplicity. The new Epson EcoTank printers. EPSON.com/EcoTank. I love them. You'll love them too, and we thank them so much for their support triangulation. It's interesting to look at a technology that's very mature, like inkjet printing, that in its infancy seemed almost impossible. Seemed like there's no picoliters of ink. What are you talking about? It's magic. You know, I think of things like DLP and inkjet printing, and it's just magical. And I think we're starting to get to an era now where 3D printing is starting to enter that magical phase, especially this 3D stereolithography really is very cool. You're happy, I suspect now, that you made the decision. What happened with that lawsuit, though? They claimed that they owned that process, right?
Yeah. So, of course, I'm not able to say too much about it, but they said we were infringing on some patents. We said we weren't, and
you've
spent a lot of
resolved
time. Spent a lot of time in court and spent a lot of money on lawyers, but we've now resolved it.
That's good, and I'm sorry. I'm sorry that happened. That's one of the things that I really fear in this country, that this kind of patent situation is going to make it harder for innovation, because you never know when you're starting a company who's going to come out of the woodwork and try to take you down. And here you are, just coming off this huge Kickstarter success, and oh my goodness, I mean, your heart must have just come up in your throat when you heard about it.
It was definitely a tough day in the office, and it was only about 2 months after the Kickstarter, so it was really a roller coaster.
But the good news continues. Not so much longer after that. You got $19 million in A-round funding, which is nice, giving you a little breathing space, I imagine.
Mm-hmm.
And what did you decide? What did you want to do with the money? What was it that you couldn't do that you wanted to do?
So, yeah, that's interesting, because at the time we were basically break even. We could have continued to run and grow the company without that money. But what we really wanted to do was build this, and we wanted to do it quickly. We knew there was so much further we could take the technology, but it would take a lot more people and money to get there. And we wanted to sort of jump to that next phase.
I mean, it's only 18 months after the Form 1 Plus. So you had the Form 1, another year later, the Form 1 Plus, and almost just about a year later after that, the Form 2. I mean, that is high speed. So you use the money to hire more people? How do you solve that problem?
So we hired a whole lot more people. We were able to, get more tools and resources to work here. I mean, the Form 2 was built. The Form 1 was built with about 6 or 7 people over the course of a year. Form 2 was like 40 people over a year and a half or 2 years. Yeah. So it's a far bigger development.
Yeah, that's amazing. And of course, the 3D printer documentary featured you as well, and that must. Do you feel like that was important? The Netflix documentary.
Yeah, that Netflix documentary was an amazing bit of luck for us.
Timing was perfect, wasn't it?
It was just so fortunate, because we got the amount of attention and goodwill that we got because of that was just incredible. And that's not something you can sort of like plan for or ask for, but those documentary guys found us and decided we were interesting enough to follow, so it worked out great.
It's still on Netflix. You can see it. It's called Print the Legend if you want to see the what is now the pioneering early days of 3D printing, just a couple of years back. It's really cool. And of course, it also documents the upset over the MakerBot sale and so forth. But certainly worth seeing. So let's talk a little bit about the process of creating something with the Form 2. It starts with Preform, which is your software, right?
Yep. So there's sort of like there's a few components of the system. We build the machine, but we also build software that runs it and materials that go in it. So it starts with the software, and basically you take a 3D model that you've developed in your own CAD software. We don't make the design software because there's all different types of design software depending on what you're doing. But they all output the same kind of file, STL file, and we take that file in. And Preform is kind of like a print driver that sets the job up to run on your machine.
Oh, interesting.
But in 3D printing, it's a little more complicated than in 2D printing in terms of what the software has to do. So if you look at this part I showed earlier, this is the part here, but it's actually resting on these support structures that you can break off. So choosing the orientation that the part prints in and building these support structures is something that used to be done by a technician running the machine. But what Preform does is automate that process. So it generates a structure, it analyzes the model, chooses a direction to print it in, and adds those supports. And the goal is really for it to go away entirely, because the computer should be able to do all those steps for you. But right now, there's still a little bit of human interaction.
Just as nowadays, when you get a printer, you can expect that it will work with an inkjet printer. Someday, we'll be able to just say, oh, yeah, it'll work with a 3D printer, no problem.
Yeah, exactly. Yeah. And so we're making steps along that way. And actually with Form 2, we're releasing a new feature in Preform called one-click print, where it will take all of those automatic tools that we've developed and run them in one step and present a job. You put the models in, you press one-click print, and then calculates for a minute or two, and then says, okay, is this good? Can I start printing?
That is another key, frankly, to making this accessible and to making happy users, is to just have it kind of be simpler to use. And then you can you also use like step files? What you can edit a broad variety of 3D files.
We take STL and OBJ files,
okay.
But basically every single CAD program will output one of those two.
Okay, STL and OBJs, and that goes into the Preform program.
Yeah.
And then the Preform controls the printer from that part. How about speed? I mean, that's the other. I guess if you're making a part and you don't mind going home and having it come back in the morning, having it be done. But is there a demand to speed these up?
There's definitely a demand to speed them up. As you pointed out, though, it's more about the time you spend on it. And so if you have to go home and let it run, that's not necessarily a huge issue. But that being said, Form 2 is the fastest desktop 3D printer. So if you run it at the same kind of settings, the same layer thickness, and the same density settings as any other desktop FDM machine, it's faster.
Okay. And they're everywhere, as you mentioned, every Fortune 500 company, including Tesla and Apple and Google. All of the design departments have these Formlabs printers in there. And I imagine they have a variety, including some $100,000 printers. What do they use the Form 2 for? Or what will they use the Form 2 for? What do they use the Form 1 for that they don't want to do on the big expensive ones?
So I think it wherever they can use it, wherever it meets the needs in terms of the materials or build volume or things like that, it lets them cut the iteration time. So you mentioned speed. In practice, a lot of the time that it takes you to get your part back in settings like that is waiting for somebody to run the job for you or waiting for it to get shipped from somewhere else. Right. So like at Tesla, the group that designs the key fobs was using Form 1, and that's a little ergonomic part with a lot of little details, and you can just keep on running a new job, 1 or 2 jobs a day, and iterate much faster than you can if you wait for the part to come back.
And give it to people and say, how does that feel? And watch people use it and all that stuff.
Yeah.
That's a big part of it, isn't it? That prototyping and the iteration over and over.
Yep. Another use case is, say, at like GE, when they're actually working with metal 3D printing, and they will print out some parts before they go to the metal 3D printer, because running a job on the metal 3D printer could be $20,000. So they'll just, double check their part.
Okay, let's do this in resin first, just in case. Yeah, that makes a lot of sense. There's a real role for it in even a big design shop like General Motors. How about color? Chat room's asking, when can we get color in these things? That's a hard thing to do?
Yeah. There's a couple of the higher end machines that are able to print in full color. 3D Systems and MCore are 2 companies who make that. And those processes are interesting, but so far you haven't been able to get full color and like good detail and good material properties. So the full color parts are usually very much just appearance models.
Yeah. I mean, the fact that you have these 6 resin choices, I think, is really huge, because you can pick. Who cares what the color is? You can paint it if you you want. What you're really looking for is the performance of the material. And I mean, having a castable material by itself is huge. I imagine jewelers, as you mentioned, are just thrilled with this. Are more and more jewelers working this way with 3D models and 3D printers?
Absolutely.
What a great way to do it.
That's definitely been a really interesting market because jewelry, a lot of people in the jewelry world are very skilled craftsmen who've been doing this for years by hand. So they'll form these wax parts with various sets of tools. And that's a great way to do some things. And those people are kind of often set in their ways.
Yeah.
But then there's a lot of people who are looking at totally new applications and new things you can do that are enabled by digital design. So there's a jeweler in San Francisco named Sarah Graham who has this product where you can come into her store and she'll take a fingerprint scan and then she'll apply it to the surface of the ring, sort of embossed in 3D. And then she prints out those patterns with the Form 1 Plus, and she can do that all in store.
That's one real advantage you have is this very fine resolution. You're quoting 25 microns for the castable material. That's incredible. And I think that the Form is the only one that I know of that can do anything like this at that price point.
It is
really cool. I want to buy one now. We make drone parts here. Do a lot of that. But some of this stuff is really fun, especially the jewelry. We're talking to Max Lobovsky. He has announced the Form 2, the newest iteration from Formlabs of their amazing stereolithography-based 3D printers. We'll talk a little bit more about some of the things you can do with the Form 2, and I'd love to hear from the chat room if you've got some questions. I know a lot of you are very much into 3D printing, and this is a chance to talk to the man in just a moment. First, though, let's talk about smart homes. Another great, this was a Kickstarter, very successful Kickstarter, SmartThings. They had an idea that if they could only make a hub and one app on a phone that would talk to the hub, and then the hub could talk to all the different devices in your home across all the different protocols like Zigbee and Z-Wave. Wouldn't that be cool? That's this is the second generation. They're also at their second generation now, the SmartThings Hub. One app to rule them all, no monthly fees, hundreds of devices they can control. And of course, SmartThings has their own kits as well that you can, in fact, we're going to get you a deal on the featured kits so you can get started. All the kits include the hub, so you're now kind of smart home ready. You can control everything, your phones, your lights, your appliances, your garage door, your front door. It'll unlock your door when you pull in the driveway. You can monitor for moisture. Great if you have a vacation home and you're worried about the pipes freezing when you're away. You can get an immediate alert on your smartphone. No contracts, no monthly fees, and the installation is, I got to tell you, so simple. You just plug it in. Use your internet, your Wi-Fi. SmartThings. It's from Samsung SmartThings. By the way, that Samsung acquired them last year, and that is huge because now this is going to be the hub to a lot of smart Samsung devices as well. The future is bright for SmartThings. And right now, if you go to smartthings.com/triangulation, you can save 10% off any featured SmartThings kit, and they'll give you free shipping in the U.S. I just got the new hub. Just came out, so I'm now going to go replace my original SmartThings hub and upgrade my smart home. Add a little IQ. smartthings.com/triangulation. Don't forget to get the 10% off the featured kit if you're just getting started. smartthings.com/triangulation. There's an example, Max, of another company that really came out of nothing thanks to Kickstarter. Kickstarter is pretty miraculous, isn't it?
Yeah, I mean, I don't think anybody saw this coming in sort of the world of venture capital or startups or anything, that companies could get a huge boost and get started that way.
Yeah.
It's pretty unbelievable.
So you 90% of your users are doing this in business, but that's still 10% of people like me who are hobbyists who just want to know more about what's going on with 3D printing. You have it looks like a pretty good section of tutorials that will help people understand. In fact, you could walk through even before you get your Formlab printer. This is a fascinating one, a tiny television. Does it actually work? Can you actually make a... This is so...
Well, there's a display inside it, but it's
cool.
kind of nice because like the window on it is printed in clear and polished, and so it takes advantage of unique materials.
So, yeah, that's nice. It really is clear. That's very, very cool. Tell me some of the fun things that you know. I'm sure you know a lot of people are doing interesting things.
Oh yeah, there's a huge range. One of my favorites is this French artist Gilles Deschauds, who has built an entire stop motion animated movie with it. He's shown it at Cannes Film Festival.
I saw that on your Product Hunt AMA. That is really cool. Let me see if I can find that. So what did he printed the pieces in the movie?
He printed the pieces, the set. He printed 2,500 parts for this movie. So there's this female character that's walking around and playing guitar, and there's like dozens of different iterations of her at different sizes for different scenes in the movie. And then there's these big sets of like trees and roots and things like that. That's actually how we first heard about him, is when he was posting on our forums really early on. He got a printer on Kickstarter, and he's sending in these photos of this like large tree he was printing in multiple sections. Yeah, that tree right there, actually. And we had to ask him, like, what exactly are you doing with this?
So cool. And again, this is where the Form 1 Plus really shines, because of the detail that you can have in here. You can really do this. So he printed each individual motion of this woman, for instance, so she could walk. Wow. This is a great idea, actually.
I think so, too.
I'm sure something you never imagined anybody doing. Chase Me is the name of it.
We really didn't see all of these different art and animation and other type applications. We did not see that stuff coming, but they've been really successful with the machine.
He printed 2,500 parts from the Form 1 Plus. That's incredible. Just incredible. I know you just released the Form 2, or you're just about to release the Form 2. I'm sure that's keeping you quite busy. But you must have a roadmap for places you'd like to go. What other things do you think, what other opportunities exist in this space that you'd like to take advantage of?
Well, in the near term, we invented this category of desktop stereolithography machine, and we're continuing to lead that with Form 2. And so in the near term, we need to keep pushing that forward. And so we've gone from 1 to 7 materials. We've advanced preform dramatically. We have Form 2 now, and we're going to continue innovating on those fronts. So as our Form 1 and Form 1 Plus customers know, we've released software updates every couple of months that have real improvements, not just to the software, but to the print performance, either better print speed, better accuracy, things like that. And then the new materials are also available on the existing machines. So we're sort of restarting that cycle again at the beginning with Form 2, and we're going to have a lot of improvements rolling out over time.
Metals? Will we see metal materials, or is that really hard to do in a desktop printer?
They are hard to do in the desktop. It's not impossible, but they also require a lot of processing sort of before and after, and there's a lot of equipment other than the machine, which is part of what makes that difficult to do. And it doesn't really it's not just about how small the machine is itself, it's sort of what the whole experience is. So that's going to be tough.
Bigger tables so we can print bigger things, car parts,
definitely bigger build volume. We increased it with Form 2.
That's pretty big. Look at that. Wow.
Yeah. But people always want bigger.
Yeah.
So that's certainly a direction. There's a lot of other 3D printing processes, and so far there's only sort of 2 that are available on the desktop. So there's a lot of possibilities there.
RF 2020 is asking, what's the cost of consumables? How much do the resins cost?
We sell, for the base clear, white, gray, and black materials, we sell them for $150 for a cartridge, which is 1 liter. And 1 liter can print. Basically, all the material goes into the part, so it depends how big the parts are. But you can print dozens of smaller parts, or sort of 5 or 10 larger parts.
Kind of hard. Depends on the part, obviously. And at some point, are we going to reassure Kanye West that you are not, in fact, a threat to his design, his clothing business?
People want me to have an opinion on lots of things. That's just
you just pass
too far afield. I can't tell you about Kanye and fashion.
That must have made you laugh. Kanye said, technology made it hard for musicians. I'm worried that 3D printing is going to make it hard for fashion designers. Don't understand that, but I guess really you're not going to be prototyping your next design on a 3D print yet. Although we could, I guess you have flexible materials. I guess you could do. Could you do textiles?
Yeah, there's a design studio that we work with called Nervous System, who we've done some nice projects with, and they're 3D printing. They have a whole dress that's printed sort of. It's kind of like a chainmail sort of design that's made with rigid links that are connected. So there's some interesting things you can do there, and definitely the flexible material can help as well.
Well, I'm sure you're very excited about your new printer. It is available now for pre-order at formlabs.com. The Form 2, and if they continue at this torrid pace, the Form 3 will be next year, or maybe you'll do a 2+ and the 3. That's pretty exciting. What you've done to move along this technology, this stereolithography technology, which I think if anybody's looked at 3D printers, it really seems to be the superior way to do this. Really an exciting technology, and it's nice to get this on the desktop. Max, thank you for your time. I appreciate it. I heard
Thank you, Liam.
Is it done? Did it bell ring there? Is it done? No? More to go?
Not quite.
Look at that front panel. That's so awesome. You can see how far it's gone. I love that. This is really sweet. Really slick. Nice. Thank you, Max. I appreciate your time. Congratulations on the Form 2. Looks to be a really exciting product, and we will be buying one right now. Our show is every Monday, 11 a.m. Pacific, 2 p.m. Eastern Time, 1800 UTC. If you want to watch live, the chat room's always great for feedback. And I see a lot of people in the chat room who are actually very interested in doing this kind of 3D printing. I know you guys are all very interested, so we're glad we could get somebody like Max on, like the guy, to talk about it. If you can't watch live, though, and you can't ask questions in the chat room live, you can always watch after the fact. We make on-demand audio and video of all of our shows available. It's at our website, twit.tv. It's wherever you can download podcasts like iTunes or Groove, or where, and of course all the podcast apps and all the mobile players. There's even a Twit Roku app. Lots of ways to watch. I hope you will find a way, subscribe, and make sure you come back every week for Triangulation. Thanks for joining me. I'll see you next time. Bye-bye.